The broadcast is now starting. All attendees are in listen-only mode.
Good morning. Welcome to the DBA Fundamentals Virtual Chapter Meeting for January, or at least our first one. Our second one, we already had one in Australia last night. Hope you were able to attend that. Today, Edwin Sarmiento will be presenting what Smart SQL DBAs ought to know about Windows Server Failover Clustering. He'll be presenting that in a few minutes. I'm going to get a few housekeeping things to take care of first. The next thing is I'm going to let our sponsor speak. And if I can get the slide up. Okay. Kevin Klein with Century One. Go ahead, Kevin.
Thanks, Steve. I appreciate that. Hi, everyone. I don't want to take too much of your time except to say that we hope you will take a look at our various products and services and offerings. Just in the middle of the slide there, if you'll notice the heading called eBooks, this is a super popular offering. We have a variety of eBooks. Right now we have 5. They're each $10 in the Kindle bookstore, but if you go to the URL listed there, we give those away. All you have to do is sign up for that, and we'll send you all of those. They're not little books. They're big, 300-plus pages each, with lots of great content. Also, do want to do a quick call out for our free product called Plan Explorer. I'm sure Edwin can speak to this as well as I know Steve uses this product. Very, very popular. It helps you tune your SQL queries. And it's so free, we don't even ask for an email address. So we hope you'll get to know us and start looking at those free offerings and take advantage. And just a quick word about Edwin. Great speaker. He is one of my favorite speakers. Always has a lot of great wisdom as well as the hardcore technology information too. So happy to see that you've decided to join Edwin on this session as well. Thanks, everyone. Much appreciated.
Thanks, Kevin. I'll definitely agree with you totally on the wisdom extra part. It's a treat going to one of Edwin's presentations. The last one I saw at PASS this year was just fantastic. Anyway, let's see. PASS has lots of other virtual chapters, and you really need to go out there and check them out. Go to sqlpass.org/VC. You can join up and get on their mailing list if you want or not. There's one on practically every portion of SQL Server and BI, and there's one for practically every major language. So give that a try and try out some of the other ones. Here's some of the virtual chapter sessions that are coming up in the near future. Questions and answers with David Klee on the virtual chapter. He is so knowledgeable, it's unbelievable. So he's just going to be answering questions about, I think about virtual systems. I mean, he'll have great questions. That's tomorrow. Women Technology has a real good one, While Learning the Business is Important from Joins to Coins. That's on the 21st. The In-Memory VC chapter is doing what every SQL Server professional should know about in-memory OLTP, and that's presented by Bob Ward. He's been with our chapter before. He's great to listen to. Another Women in Technology session is the Introduction to Oracle's SQL and PL/SQL. Now, I looked at this one a little bit. You know, 95% of us are pure SQL servers, but there's a lot of possibilities of where we're going to be touching Oracle or PL SQL in our environments, and this sort of gives you an overview and does a compare and contrast so you'll kind of at least have a background, so that's useful. Today we have our answering, let's see, let me back that up, I'm sorry. Okay. The first one we have in February is answering the question, what happened with SQL with Query Store by Aaron Stellato. And on the 17th of this month, we have Kevin Klein, who is online with us right now, and he'll be doing his session that goes over his ideals of performance tuning methodology. And I think that's not exactly the title of it, but that's the gist of it, and that's a fantastic topic that we've been trying to go over. Partitioning basics, treating your tables like Legos. That's in our Down Under chapter in February. And stored procedure optimization techniques by Kimberly Tripp. Those are the upcoming ones. As you can see, we've got a lot of from SQL Skills and the SQL Tiger team, and Glenn Berry, and then we have Brent Ozar again in April. This recording will be saved, and it'll be at these locations. If you want to hit the little camera at the top right-hand side of your screen, you can save these locations, either at our YouTube site or at fundamentals.sqlpass.org. SQL Saturday is like a mini Pass Summit that's usually in your area. I really suggest you take advantage of this. Usually you have to pay for your own lunch, and that's about it. And you'll have a full day of sessions from speakers from all over the U.S. There's one coming up in Nashville, which I'll be attending this weekend. If you're in the area, definitely check that out because it's usually one of the better ones in the area. As you can see, and if you have any others during the broadcast, if you want to mention it, I'll do a shout out for them also. Pass wouldn't operate if it wasn't for volunteers. One of the things that's so great about the entire community is everybody is willing to volunteer, or almost everybody, and there's all sorts of different levels you can volunteer. Hosting a virtual chapter like we do, doing presentations at SQL Saturdays, presenters doing presentations, which is free education. There's lots of different ways. Go check it out. Okay. Back to our presentation. Today we have Edwin Sarmiento doing what Smart SQL Server DBAs ought to know about Windows Server Failover Clustering. Edwin is the Managing Director of 15C, a consulting and training company that specializes on designing, implementing, and supporting SQL Server infrastructures. He's a SQL Server MVP, Microsoft Certified Master from Canada, specializing in high availability, disaster recovery, and system infrastructures, running on Microsoft Server technology stack ranging from Active Directory to SharePoint and anything in between. He's currently going to be talking about what Smart SQL DBAs ought to know about Windows Server Failover Clustering, and he is presenting from the Philippines this morning at 1 a.m. So I'm going to turn it over to Edwin. Let me make you the presenter.
All right. Good morning. There we go. Hope everyone can see my screen now. All right. Good morning, good afternoon, or good evening, wherever you are. In my case, I'm actually about 14 hours ahead of you guys. My name is Edwin Sarmiento, and this is a presentation on what Smart SQL Server DBAs ought to know about Windows Server Failover Clustering. I really appreciate the introduction, Steve and Kevin. Much appreciated. I have utmost respect for Kevin, of course. I wish I could talk more about Plan Explorer because I use it personally, but this is more of a high availability presentation. Questions, if you do have questions, feel free to use the chat option. Type in your questions. We could answer those questions at the end when we have time for Q&A. Look me up on LinkedIn, Twitter, on email, or on my blog. I write on a regular basis about SQL Server high availability and disaster recovery. Whenever I ask people about clustering, I just want to start off with this because it's been my experience when I was starting out as a SQL Server DBA. And it's something that I ask customers, even folks who take my training classes, what they think about failover clustering in general. And this is something that I kind of find as a common theme. Complex, very complex. 3 keywords that keep popping up in conversations. It's complex, it's confusing, and it's complicated. The fact, of course, that the Microsoft documentation is not helping us understand how the technology works. And here's the thing. Everyone tells me the same thing. There's a lot of moving parts, a lot of components involved. That's part of why it's so complicated and so confusing. And so, you know, when I was starting out as a SQL Server DBA, I felt the same way. And I can't blame them because I felt the same way. In fact, I kind of use the story or the analogy of when I was visiting the UK. I was at SQL Bits a couple of years ago, and I, you know, decided just for fun, rent a car. Now, when I'm in the US or North America, I do the same. I rent a car, drive around as much as I can, but being in London, in the UK, is quite different because they're driving on the other side of the road, which means everything when the car looks exactly the same, except that, you know, the driver has to be sitting on the right side of the car, kind of like the British would always say, we're actually driving on the right side of the road. It's kind of confusing. I know for a fact that I know how to drive, but when I hit the road, it's as if I didn't know anything. And I felt somehow confused because, you know, same thing, I was driving. I know for a fact that I know how to drive, been driving for years, but when I was on the road in London, it felt like I didn't know anything. And that's practically, that's basically how I felt like when I was driving in London, and practically the same thing as I felt when I was starting out exploring Windows Server Failover Clustering. In fact, I tried to avoid working with anything related to Windows Server Failover Clustering until I realized that, you know, there's some negative truth about the statement, because I don't have to be intimidated, because the fact is I actually know a few things. Driving in London means I know how to take the skills that I've learned driving in North America from you know, where I started learning how to drive, and take them as a starting point for learning how to drive on the other side of the road. And it's practically the same thing. And this is something that I've realized. It's the secret to understanding the complex, whether it's driving on the other side of the road or learning Windows Server Failover Clustering. The secret to understanding the complex is to start what we already know. In my case, I knew how to drive a car. I knew how to signal if I'm turning left or turning right, same thing. And as we're going to look at Windows Server Failover Clustering, I'm going to explain concepts that you probably are aware of, and all you have to do is use that as a starting point for learning Windows Server Failover Clustering. Now, everything that I'm going to be talking about here will be using the context of SQL Server as a workload, whether it's failover clustered instance or availability groups. And the goal here, and just to set the stage, every time I work with Windows Server Failover Clustering, be it for failover clustered instances, availability groups, or even for non-SQL Server workloads such as Microsoft Exchange for that matter, the goal of high availability is to keep applications, systems, and services readily available. That's the goal. So let's get started. And the one key takeaway that I want you to keep in mind in this session, it's this. Failover clustering is simple. Now, you might be thinking, well, he's oversimplifying, but I want you to really think about this. Failover clustering is simple if you remember these concepts. Again, trying to simplify things because I know it's complicated, it's confusing, it's complex. Again, the fact that the Microsoft documentation does not help us understand better how the technology works, but if you remember these concepts, again, which is why the entire session is entitled What Smart SQL Server DBAs Ought to Know, just remember these concepts. The first concept to understand how SQL Server works together with Windows Server Failover Clustering and how SQL Server runs on top of Windows Server Failover Clustering is what I call the traffic light. Now, everybody who drives probably knows, well, I would assume you should, or you must know, how the traffic light works. And I'm going to use this as a very simple example to explain how Windows Server Failover Clustering works within the context of just about any other workloads. And again, you can take these concepts and apply them to just about anything. The only thing here is that we're focusing on SQL Server workloads. Think of the 3 states of the traffic light. The first state is the red light, or what I kind of call the stop service. Failover clustering provides high availability to any workloads running on top of it. This is multiple computers working together, and only one computer in the system is acting as the active node. If you decide to move the service, let's say SQL Server, from that server or that node to a different server, the process would start stopping the service. This is, again, whether it's intentional, maybe you're doing patching, or accidental. You know, maybe the server blue screened or the server hardware failed. As the service is stopping, the second phase is the waiting phase. This is the part where the cluster will have to wait. Wait for what? Wait for dependencies, wait for other components that need to be available before it even starts to start the service on the next available node. In a 2-node Windows Server Failover cluster, if one of the nodes fail, the other server has to be ready before the cluster can start the SQL Server service in that particular node. If you understand how traffic light works, it's pretty much easy to understand how Windows Server Failover Clustering works. Again, regardless of what type of workload runs on top of it. And I want to show you how it works visually using the traditional 2-node cluster with SQL Server Failover Clustered instance. The reason I use this example is because it's been there ever since the good old days of SQL Server 7 running on Windows NT 4. Traditional 2-node SQL servers running on the server on the left, typically known as the active node, and the server on the right is acting as the standby node, and you got your shared storage. Let's emulate the traffic light analogy in order to understand how this thing works. And I'm going to throw in an application, of course. Your SQL Server workloads are totally useless if you don't have an application connecting to it. So your application is connecting to your SQL Server instance. The service is currently running, on the server on the left. Let's assume something happens. Let's say a blue screen, or again, hardware failure. This is where the stop phase kicks in. And the waiting phase is when the cluster decides, is the server on the right ready to take over the workload? That's part of the waiting phase. And the start phase is when SQL Server gets restarted on the server on the right. The former standby node now becomes the active node. Now, of course, keeping in mind that because you're simply stopping and starting SQL Server, this is no different from running crash recovery, because you're stopping SQL Server and restarting SQL Server on the former standby node. Once the SQL Server instance is back online, or the SQL Server service has been started on that node, the application can then reconnect back, of course, depending on how the application was rewritten, or written rather. Again, because of the fact that it's stopping the SQL Server service during the failover process, the application will get disconnected. And again, I'm using the traditional 2-node SQL Server Failover Clustered instance here as an example with shared storage underneath. But when you start introducing SQL Server availability groups if you're running SQL Server 2012 and higher. The concept is practically the same. Of course, with an availability group, you don't have shared storage because the instances could be standalone instances working within the availability groups. That's how Windows Server Failover Clustering works at a high level using SQL Server workloads as an example. Now let's look at some of these definitions, because these definitions are what form the foundation of how Windows Server Failover Clustering works. Let's start off with a very simple definition of a cluster. A group of computers and storage devices that work together and that you can access as a single system. Now let's break down this simple definition and highlight some key points. Number one, it's a group of computers and storage devices. Notice that I got an asterisk on the storage devices because starting off with Windows Server 2008 and higher, you can opt to build a cluster even without shared storage devices. Now, because the goal is high availability, you need to have more than one computer in the cluster working within that group and working together. So they should be a group of computers, may or may not have shared storage devices. They have to work together, and they should be accessed, or they need to work as a single system. I mean, think about this: your Active Directory, your Exchange, your SharePoint, your SQL Server, your file servers. These are a group of computers working together, but they're not necessarily a single system. And so this definition in itself, the simple definition, defines what clusters are. And again, it's not necessarily just tied into the Microsoft technologies. Even non-Microsoft technologies can have this as the definition for failover clusters. And you could add as many servers, and we're going to call them nodes later, but you can add as many servers in the cluster to provide higher availability for whatever workload you're running on top of it. Now, as I mentioned, we're going to look at some of these components, and we're going to take a look at these components and how they form the foundation for understanding how Windows Server Failover Clustering works, and how each of these components contribute to meeting high availability for each of the workload or whatever workload that you're running on top of the Windows Server Failover cluster. The first one is a node. I somehow mentioned this briefly earlier. A server that acts as a member of the failover cluster is called a node. And I'm going to highlight that using the red circle to highlight each of these components. Now you can have as many nodes as you possibly can afford. Windows Server 2012 R2, I believe, you could build a Windows Server Failover cluster with 64 nodes. Of course, the more nodes that you have, the more complicated your deployment becomes. But again, it's just a server acting as a member of that particular cluster. The next is the concept of a resource. So this could be a hardware, a service, or an entity that's hosted on top of a cluster. Now, there are different types of resources. Kind of categorize them in two, physical and virtual. Okay? Resources form the basic building block in a failover cluster. Every component that you would see in a failover cluster is treated as a resource. Now, as I mentioned, you got two types of resources: physical resources, your nodes act or are an example of a physical resource. Now, of course, you can argue that you can either have a physical or a virtual machine, but at the end of the day, a node needs to run on something tangible, in this case, a physical machine, even if the nodes are running as virtual machines. Your network, again, you need the cables, the routers, and the switches, again, with physical representation of the resource objects. And then you got the storage. Again, quote-unquote storage, because in the days of availability groups, you don't necessarily need shared storage. But again, let's throw that in, because if you're going to be dealing with failover clustered instances, you definitely need shared storage. So those are examples of physical resource. What about a virtual resource? I just threw this definition in again for the sake of covering SQL Server Failover Clustered instances that require shared storage. And the storage is owned by only one cluster node at any given point in time, even though all of the servers or all of the nodes are connected to the shared storage. Only one server or only one node can own the shared storage, and the pathway to the shared storage can only be through the node where the current service is running. So the I/O workload in this case can only go through the server on the right where the SQL Server instance or the SQL Server service is running on top of. Of course, this becomes even more complicated when you start introducing the concept of cluster shared volumes in SQL Server 2014. But again, the only reason I threw this in is because if you're going to be dealing with failover clustered instances, you need to have shared storage. And then we have virtual resources. Virtual resources are things that, or objects within the Windows Server Failover Cluster that do not have a physical representation. An example of this is the virtual server name. You know, when you access your SQL Server Failover Clustered instances or your availability groups, you need to have a virtual server name. And the virtual server name is a representation of the SQL Server workload. Okay? The way you access the resources in the cluster is not by accessing the server names. You have to access the resources by using a virtual server name. I kind of call this the DNS alias sometimes, because again, the virtual server name can move from any of the nodes within the cluster. Again, it's part of the whole concept of high availability. And then, of course, the virtual IP address that maps to the virtual server name. So when your application connects to it, and again, whether it's failover clustered instance or an availability group, in an availability group, you're going to be using the listener name. And the listener name is nothing more but a virtual server name with a corresponding virtual IP address. I did mention that in order for you to really understand the concepts, we need to start with what already know. So I'm going to draw parallels between standalone instances and failover clustered instances. And again, the concept applies whether you're working with failover clustered instances or availability groups. So let's look at a standalone instance and draw parallels between these two. Let's start off with the host name. You know, in a standalone instance, the SQL Server instance name is, it will use either just a host name if you're dealing with a default instance, or the host name / instance name if you're using a named instance. So the host name in a standalone instance is equivalent to the virtual server name for a failover clustered instance. It's also equivalent to the availability group listener name in an availability group. Of course, you have your physical IP address. The only way for you to access a SQL Server instance, whether it's a standalone instance or a failover clustered instance across the network, is if you know the IP address. Of course, we don't memorize IP addresses, so the way we do that is by using the host name, and the host name is mapped to the physical IP address. And the same thing with failover clustered instances. You know, we access the virtual server name, and the virtual server name has a virtual IP address attached to it. As I mentioned earlier, the virtual IP address and the virtual server name are not tied into just one server or one node in the cluster. It moves back and forth between the members of the cluster. And again, part of the high availability strategy is if one of the servers go down, the virtual server name can move from the failed server into any of the available standby servers or nodes in the failover cluster. And of course, in a virtual IP address, your network adapters use those IP addresses so that the workloads or the client applications can connect to our SQL Server instances. Key point here, an IP address can only be assigned to one network adapter at a time. This is one of the reasons why in your network, if the network identifies a duplicate IP address, you would see a prompt telling you there's a duplicate IP address in the network. Okay, but then a network adapter can have one or more IP addresses. The fact still remains, an IP address can only be assigned to one network adapter at a time. And again, throwing in here storage as well. Your databases, system user databases can be stored on shared storage for virtual, or rather for failover clustered instance, and local storage for standalone instances. And like I said earlier, a storage subsystem can only be owned by one server or one cluster node at any given point in time. Next, we talk about resource groups. I got a love-hate relationship with how Microsoft named resource groups, but I still go back to how it was named in the good old days of Windows NT4, and they're called resource groups because basically that's what they are. They're a group of resources, a combination of resources that are managed as a unit or as a group. I kind of think of them as your utility bill. You move to a different city, you take your cell phone with you, or your cable, or your internet subscription with you. You ask the service provider to move the service to the new location, but at the same time they're going to change the billing address. You can't decouple your service from your billing address or from your bill. They have to go together. Otherwise, you might end up having internet subscription today, gone the next month because you weren't able to pay your bill. Think of resource groups that way. You cannot decouple any of the group, or rather any of the resources within that particular group. Like I said, I've got a love-hate relationship about how Microsoft named resource groups, because in Windows Server 2008, Microsoft started calling this services and applications. Within the Failover Cluster Management Console, it's called services and applications. In Windows Server 2012, Microsoft called this roles. I don't really care how Microsoft calls them. I still want to call them resource groups because, again, they're basically a group of resources managed together as a unit. Again, drawing parallels between standalone instances and failover clustered instances, and this is, we started off with one-to-one mapping between the host name, the physical IP address, the storage and whatnot. Let's again draw parallels on how we could consider groups or resource groups from the point of view of standalone instance and correlate that with how we look at failover clustered instances. So when you look at a group, the host name, the physical IP address, the SQL Server instance or the service, and storage are all part of the group. What do I mean by that? Well, you can't simply take the database files off of that storage, move it to a different server, and still access it using the same host name as its original server. It's one of the reasons why when we do migration and upgrade to a different hardware or different machine, we have to take everything with us. We have to install a new copy of SQL Server. We have to do a backup and restore of the same database. We have to point Applications redirect applications to the host name or the instance name that are mapped to those particular databases within that storage. And you can't even just remove the storage altogether. Okay. Similarly, in a failover clustered instance, when you're grouping all of these together, like the virtual server name, the virtual IP address, the SQL Server service, or in this case, I'm going to start calling it resource. The SQL Server resource and the storage are now inside a resource group, which means every time you access your SQL Server instance, all of these components factor in for SQL Server to be online, available, and accessible. I can't move the virtual server name and let it run on the server on the left while the SQL Server resource is running on the server on the right. If the virtual server name is running on the server on the left, everything else should be running on the server on the left, which means even the shared storage is managed by the server on the left, or owned by the server on the left. Again, regardless of whether this is a failover clustered instance or an availability group. This would slowly ease you into understanding how SQL Server failover clustered instances and availability groups work, because they're now working as individual resources now grouped together and managed as a single unit called a resource group. Next, we have the concept of a failover, and failover is nothing more than moving a clustered resource from one node to another. And look at the diagram and you'll see the SQL Server clustered resource running on the server on the left. When you do a failover, again, the concept of the traffic light kicks in. You're going to stop the SQL Server instance on the server on the left. The waiting phase kicks in, and you're going to start the SQL Server service or the resource on the server on the right. And again, just going through the entire stop, wait, start phase, or the traffic light analogy of how the failover process works in the context of a SQL Server workload. I introduced Active Directory and DNS over there because this is the part where I usually tell SQL Server DBAs, look, whether you like it or not, your career is now dependent on the things that you're not even aware are dependent on, which means your capability to keep a SQL Server resource that's running on top of a Windows Server Failover cluster now depends on the Active Directory guys, now depends on the DNS server administrators, your network administrators, which is why you really need to be very nice to those folks. So part of the failover process is understanding what is going on under the covers. Now I know you might be thinking, well, I'm not an AD guy, I'm not a DNS guy, and I get that. But understanding that there is a dependency for your SQL Server failover clustered instance or availability group, there is a dependency in Active Directory, which means, again, your availability and the way you meet your SLAs and recovery objectives are now dependent on Active Directory and DNS. Well, it's been like this ever since. Any SQL Server workload running on Windows Server failover clusters have been dependent on Active Directory ever since. The only difference, of course, is that if you're dealing with standalone instances, you barely notice the dependencies because, well, your applications can connect to it. Authentication just happens if you're using Active Directory authentication. But now, with availability groups, you're starting to see direct dependency between SQL Server running on a Windows Server failover cluster interacting with Active Directory and DNS. I mentioned dependencies, and dependency is basically just the reliance of a resource on another resource. And I'm going to use the image or the graphic that I mentioned, showed you earlier, and draw parallels between the two. I'm going to start off with the SQL Server agent. Of course, you might be wondering, are we just talking about SQL Server, the database engine? Well, of course, we use the SQL Server agent a lot to make sure we perform some of the automated tasks that we need to do. Part of that is understanding that even on a standalone instance, I won't be able to start the SQL Server agent service unless the SQL Server service is started. Therefore, we could say that the SQL Server agent is dependent on the SQL Server service. Let that sink in for a bit. Because what you're seeing here is the fundamental principle behind troubleshooting availability groups or failover clustered instances availability. Okay, so going back here, your SQL Server service or cluster resource is dependent on two things. It's dependent on the virtual server name, and it's dependent on the underlying storage. I mean, think about it. If there is a duplicate IP address on the network, your applications won't be able to connect to the standalone instance, even if you have a physical IP address mapped to the network adapter for that machine. If you have a duplicate DNS name, same thing. Because you've got two resources where SQL Server resource is dependent on, I need to have both the virtual server name and the shared storage to be available in order for SQL Server resource or the SQL Server service to be online. I mean, think about this. If the master database is unavailable, again, whether it's on a standalone instance or a failover clustered instance, you won't be able to access your SQL Server instance. That's where the storage subsystem comes in. So you need to have both the virtual server name and the underlying storage subsystem where your SQL Server databases are stored in order to make sure that the SQL Server service is started. Either one of those coming offline will cause your SQL Server clustered resource to go offline. I mean, you've probably had this issue before, where even on a standalone instance, you try to start the SQL Server service, but it won't. Turns out that the drive containing the master database, the system databases are offline, and therefore you can't start a SQL Server service. Okay, that's an example of an AND dependency. SQL Server is dependent on the virtual server name and the underlying storage subsystem. Next, we have the virtual IP address. The virtual server name is dependent on the virtual IP address. Now take a step back and recall how I showed the dependency of the entire cluster on Active Directory in DNS. If my virtual IP address could not come online, let's say there's a duplicate IP address on the network, my virtual server name will not come online. Of course, as a side effect of that, my SQL Server instance, my clustered SQL Server resource, would not come online. And again, as a side effect of that, SQL Server agent service will not come online. As I mentioned, you are seeing the fundamental principle of how I start my troubleshooting process for identifying availability issues in a failover clustered instance. So I'll use this as an example for let's say at one point your SQL Server instance went down. I need to know what's going on and how I could bring it up. All I have to do is just look at the dependency report within the failover cluster. That is the first thing that I look at when I'm troubleshooting availability issues in a failover clustered instance or an availability group. Side note though, I'm going to be doing a presentation for the HADR virtual chapter on Thursday on troubleshooting availability issues for SQL Server workloads running on Windows Server Failover Cluster, where I talk about how I go through the process of identifying issues by using, again, the simple concept of dependency within a resource group. So that's dependencies, resources, resource groups, and all of the different components working together to make sure that your SQL Server Failover clustered instances or availability groups are kept highly available. Of course, in an availability group, you won't have the storage for standalone instances acting as replicas in the availability group. The next concept is what I considered the most complex, the most complicated concept, yet the most important one in a failover cluster, the quorum. Now, the quorum determines the number of failures that the cluster can sustain while still remaining online. I kind of simplify the concept as majority vote wins. Every node in a Windows Server Failover cluster contributes to a vote. The goal is to make sure that every voting member can contribute to a vote and get majority of votes to make sure that the cluster can stay online. Of course, if the cluster can stay online, all of the resources running on top of the cluster can stay online. Again, that's the goal there. Looking at the diagram, we'll use the traditional two-node Windows Server Failover cluster, running SQL Server Failover clustered instance in this case. If the goal is to have odd number of votes or majority of votes, and if every node contributes to vote, just by looking at this diagram, we could easily see that I only have 2 votes. Well, one for the server on the left and the other one for the server on the right. That's not an odd number of votes, because if one node goes down, well, 50% is not majority. And this is where the introduction to the different quorum types come in. You need to introduce an extra voting member as a tiebreaker to make sure that you have, or you can meet the goal of having an odd number of votes to meet majority. So this is where you introduce, and this is where a lot of people get confused, because it's been like this ever since the good old days of Windows NT. You introduce the shared storage as a disk witness. So basically the disk now contributes to the vote towards the quorum. In this case, instead of just relying on 2 servers that have votes toward quorum, I now introduce a third vote in the form of the shared disk. Shared disk contributes to the vote. So if one of the servers goes down, I've got 3 votes. One vote goes down. 2 out of 3 is still majority. Anything greater than 50% is majority. And because it is majority, the cluster can stay online. And the reason I say this is very important is because of the fact that a lot of people get confused with this. In fact, I vividly remember 2013, when SharePoint 2013 came out. One of my customers asked to help build an availability group for their SharePoint farm. Now, I do a lot of SharePoint, but they didn't ask me to build a SharePoint farm for them. So I built the availability group infrastructure for them. Because they're using standalone instances, I simply used a file share witness. The file share witness is running on a clustered file server. As I was building the availability group, I noticed that there were some issues with the file share. I noticed that every once in a while the file share would go offline. And I told them, look, you got to monitor. You got to monitor your file share. Quick segue to SentryOne, if you want to use SentryOne for monitoring. But the point of the matter is I told them to monitor the file share because I'm seeing issues. Could be networking issues, could be access issues on file share. But I told them specifically, I see a lot of events in the Windows event log about the file share. Monitor this because it will impact your availability. And this is Windows Server 2012. First release, not R2. At one point, they decided to apply Service Pack to SQL Server 2012. I know for a fact that the file share is still causing some issues and it's going offline every once in a while. They started off installing the Service Pack on the standby node. Of course, everybody's not even considering the fact, hey, there's nothing wrong with the primary replica, and we're patching the secondary replica. There shouldn't be any issues. A reboot was required. They rebooted the secondary, and down goes their SharePoint farm. And they called me. And they blamed me for it. And I told them it's by design. And they were shocked when I said that. And I told them, look, I have 3 votes in my cluster. I told you to monitor your file share witness because I'm seeing issues in your file share. The file share is unavailable. I got 2 votes left in the cluster. And then you rebooted 1 of the 2 votes. 1 out of 3 is no longer majority. So what does the cluster do? Well, it doesn't have majority. It will take the entire cluster offline, taking the availability group offline with it. Of course, it's a standalone instance. I can still connect to the instance. I can still query the master databases. I could, or the system databases rather. I can run DMVs off of it fine. But all of the databases in the availability group, they're unavailable because they're running inside of the availability group, and because the availability group is running on top of a Windows Server Failover cluster. The cluster took it offline because it did not meet majority of votes. Like I said, this concept is one of the most complex, one of the most complicated, yet the most important one in a Windows Server Failover cluster. In fact, there is more to it than this because every version of Windows Server, starting off with Windows Server 2008, behaves differently in terms of the quorum. So you really need to understand how the quorum contributes to the availability of, again, your failover clustered instances or your availability groups. This is the last one in all of these definitions and concepts, is the heartbeat. And a heartbeat is the internal cluster network used to monitor each node's status and communicate with each other. I call this the "Are you okay? Are you fine?" communication. Every server that's part of the cluster will send heartbeat messages to every single one of the members of the cluster. So if you got 5 servers, 5 nodes in your cluster, server 1 would have to send heartbeat messages to all the other 4 members. All the other 4 members would have to respond. And if a heartbeat message is missed after certain intervals or after certain thresholds, that particular server is considered offline, and therefore the vote towards the quorum is no longer considered. Now, The behavior, of course, is different depending on the version of Windows Server that we're working with. But the idea here is that every single one of the servers or the nodes in the cluster will have to send heartbeat messages to every single member server to make sure that they're okay, they're fine, are they healthy, are they communicating back, and that determines how the quorum gets voted in and out from the different members. This is also one of the most important concepts because in the past, Windows required that you have a dedicated heartbeat network just for the communication or the inter-node communication. Windows Server 2008 allowed you to build a cluster even with a single network adapter, and that's fine. Not a big fan of it because, well, there's a reason why you're building a failover cluster. You wanted high availability and resiliency. If you only have a single network adapter, then that becomes a single point of failure. And so, again, one thing to keep in mind in terms of how you design your failover clustered instances or your availability groups or any workload that is running on top of a Windows Server failover cluster. I've covered some of the basics, the fundamentals, starting off with the traffic light analogy of how Windows Server Failover Cluster deals with any workload running on top of it. Again, looking at a SQL Server Failover Clustered instance or even an availability group, it's nothing more than just stopping the service, waiting until any of the available nodes are ready to pick up the slack, waiting until all of the dependencies have been verified, and then starting the service on any of the available standby willing to pick up the slack. In an availability group, of course, you're not technically starting the SQL Server service because the services are already offline. You're basically taking the availability group offline and bringing it back online on any of the standby or the secondary replica for that matter. Now, I've taken the liberty to explain some of those concepts. In fact, what I just talked about is a snippet of an online course that I created last year. And it's something that I've worked hard for the past couple of months. It took me a decade long to really learn and understand all of these concepts because, again, all the confusing documentation from Microsoft and different components working together, it's so confusing. So what I did was to collect that decade-long experience, wrapped it in an online course, and simplified the concepts for everyone to take advantage of. Now, this is a limited time offering. The first iteration that I did for this, I did back in July, and I only opened registration for 2 weeks, and that's because I want to really give you the best of the most of what I can offer in terms of the learning experience. In fact, I see some folks who registered for my course the last time, and they're here on the webinar. Really appreciate you guys attending. But again, this is basically taking all of the learnings from the past 10 years and pouring it into this online course. It's a limited time only course, and I just opened registration yesterday, and it's gonna run for the next 2 weeks. But something that I really want you to pay attention to, you can actually access additional resources on learnsqlserverhadr.com. Within the next couple of days, all you would see on that site will be references for the Windows Server Failover Clustering for the Smart SQL Server DBA course. Part of the bonuses that I'm actually offering is I'm going to be giving away as part of the package the SQL Server High Availability and Disaster Recovery course, which is more like an end-to-end course that covers backup, log shipping, database mirroring, availability groups, failover clustering at a high level. how to build a personal lab for deploying SQL Server on Windows Server Failover clusters, because these things need to be tested, they need to be applied in real life, and I'm going to show you how you could build your own personal lab without blowing your budget. I mean, you could literally spend a maximum of about $700 or $800 for hardware just so you can build a personal lab. And a part of that is the design and implement a hybrid SQL Server HADR solutions with Microsoft Azure. Total value of $1,900, but again, between now and within the next 2 weeks, I'm going to throw them all in as part of the package. So if you are interested, again, visit learnsqlserverhadr.com. The registration will close on the 22nd and will reopen until further notice. Like I said, I want this to be an exclusive group where we could, it's not just an online course, but a community where we could learn from each other, and part of that is mentoring and coaching and throwing in additional resources as part of the registration process. So again, I want you to really take advantage of this offering. If you have any questions, feel free to take a look at the website learnsqlserverhadr.com, as well as my blog. Send me an email. If you like this session, please do shout out on Twitter about how what you like about this, and ask questions. There's the chat window on GoToWebinar. Type in your questions, and we're going to answer those questions for you as we still have time for this particular session. Thank you.
Okay, thank you, Edmund. I just wanted to put in a personal plug myself. I signed up for the course in July, and through procrastination, I haven't really done anything with it yet. My main interest was because I love the way Edmund explains things, and I like the addition of setting up the personal lab, because you got to really test this stuff. You don't want to test it at work. So anyway, I'm going to be actually starting with this second group and working with it, because I really want to learn about this. Anyway, we do have some questions, and before people leave, because I know we're getting close to time that people leave, be sure and sign up for Kevin Klein's session next week on his performance tuning methodology. He's been around this for a long time, and he really knows his stuff. Anyway, first question: in an AG mode, does the cluster name and the listener name have their IPs always mapped to the primary node, whether or not we fell over?
Great question. And like I said earlier, in an availability group, your listener name is nothing more than a virtual server name with a corresponding virtual IP address. Now the question was, does this always stay with whatever it is that is acting as the primary replica? And the answer to that is the concept of the resource group, because everything is a resource group. Wherever that resource group moves, every unit, every resource in that group moves with it. So the listener name will always be in the primary replica, will always be mapped to the primary replica as a side effect of it being a part of the clustered resource group.
Okay, this one is sort of a side question, but it's kind of somewhat pertinent. Is SQL Azure implemented as a failover service so that my databases in SQL Azure are getting most of the benefits of failover clustering, and is it configured and managed by Microsoft for me?
I can't really comment on the underlying architecture behind Azure, but something that I usually tell my customers, well, if Microsoft promises you 99.99% SLA in terms of failover, and they've got replication underneath, and you can easily switch over, what do you think is the underlying technology that makes that happen? And so you go figure that out. But again, just think of it that way, right? The right technology with failover and replication and seeding sounds like availability group to me. But again, like I said, I really can't talk about that much in detail.
that's the one that I wanted to. I brought that in because even though I might have left that question out because I didn't know. Anyway, I wondered if you knew. Do you lose data during the failover switching?
It's a really good question that a lot of people have been asking, and which is also one of the reasons why I started off with the traffic light analogy. In a traffic light analogy, we're stopping the SQL Server service. Now, when you stop the SQL Server service, what happens? Well, uncommitted transactions, or every single transaction, gets written to the transaction log file. Crash recovery occurs. Part of crash recovery is it will run the redo process, where it will redo all of the committed transactions, and it will run the undo process, where it will roll back all of the uncommitted. Rather, it will roll forward the committed and roll back the uncommitted. Typical question is, will I lose data? And my answer to that is, well, you'll only lose data to the extent that you've not committed the transaction. One of the reasons why availability groups claim, especially in a synchronized availability group configuration, one of the reasons that Microsoft claims that there is zero data loss in an availability group is because of the concept of the two-phase commit. The transaction log record has to be persisted on both the primary and the secondary in order for the transaction to be considered committed. Now, what if in the middle of a transaction you manage to commit the transaction log records on the primary, but they didn't make it to the secondary, and then you fail over? What happens to that? Technically, because the transaction log records didn't make it to the secondary, they're considered uncommitted. From the point of view of the transaction, you didn't actually lose any records because they didn't make it there in the first place. And so again, understanding how the underlying mechanisms work, and again, the concept of crash recovery is still working as part of the whole failover process. Again, it's one of the reasons why I started off with the traffic light analogy, to give way to the concept of crash recovery happening as part of the failover process.
Okay. This is a person asking about the class. What level do you need to be to enter the course? They're a newbie on Windows Clustering, and I'm basically a newbie, but anyway, you can just answer that real quickly if you want to.
Great question. The class was designed with a beginner in mind, and it takes you from, somebody who's only familiar with Windows Server operating systems and basic understanding of SQL Server, to making sure that you're now deploying multi-instance, multi-node SQL Server Failover Cluster. So whether you're a newbie or a beginner, you could start off. And what I did there is I designed a course with different modules so that you could jump around if you feel like I don't really need the basics. I just need to jump in configuring multi-subnet failover clusters. Then you could do that as well.
Okay, if an application doesn't support the multi-subnet failover equals true feature, how can you point an app server to the always on server when it fails over?
Great question. Talks about multi-subnet failover, and this is not just applicable to availability groups. It also applies to failover clustered instances where you're replicating the underlying storage. Now the question is, if your application does not support a multi-subnet failover cluster equal to true parameter in the connection string, what do you do? And this is where you really need to be very comfortable with automation and process improvement. And what I mean by that is, well, because the application will have to know where the virtual server name or the availability group listener name is, it's just a matter of pointing it to the right IP address. So because we know that the virtual network name or the listener name is basically just a DNS entry with multiple IP addresses, you may have to either add the new IP address, delete the old one, flush the DNS client cache, and repoint your client applications to it. Now, you don't want to be doing that manually, and this is where the power of automation using PowerShell or scripting can come in. But the idea there is, if your client application can support it, You can use host files if you want to. Of course, I'm not going to be doing that if I've got like thousands of client applications. Or manipulate the DNS server to only display the appropriate IP address. But again, that requires understanding how DNS works and how the client redirection works with various IP addresses for the listener name. And the same thing for virtual server name for failover clustered instances.
Okay, there's one user here that's got a fairly detailed question. What I'll do is I'll do the other ones that are generic. Do you have a tip for when SQL agent doesn't get installed as a cluster resource into the SQL Server resource group for adding it after the installation is already done?
Great question. In fact, I have an article written on mssqltips.com about the whole process, and the process walks you through. So what happens? I don't have a SQL Server agent in my failover clustered instance. I need to repair it. What do I do? And I walk through that process. So do a quick search on MS SQL Tips, my name, and SQL Server agent, or fix SQL Server agent.
Okay. This user's wondering about a third-party software. What do you think about using software like DoubleTake for SQL failover instead of the baked-in support? This user is probably comparing and contrasting to Microsoft stuff to third-party stuff.
Great question. I talked to the folks at DoubleTake at the past summit. We were looking at it from a customer point of view a couple of years ago, and here's my take on it. I usually look at solutions like this not from a technical point of view, but from a finger-pointing point of view. And the reason I say this is I was at a client engagement the week after the past summit, and this is a global travel e-commerce site. You probably know what I'm talking about here. And the thing here is they're cursing their underlying storage subsystem because they're losing hundreds of thousands of dollars because of it. And the problem with that is the storage vendor points to Microsoft for causing the issue, and Microsoft telling the storage vendor, here's the event log, here's the debug logs that point to. And what I'm simply pointing out here is, at the end of the day, the more components you introduce in your system, the more complex it becomes. And the more complex it becomes, the more complicated it is to manage, not to mention the non-technical aspect of it. Are you going to call DoubleTake? Are you going to call a third party? How fast can they come back to you? What's your support agreement like? We don't talk about these things when we're implementing a solution, but at the end of the day, these things factor into the availability of your SQL Server Failover Clustering instance or availability. But at the end of the day, again, you go ahead and test it out, do a POC, and if you're satisfied, go implement it. But again, don't just factor in the technical aspect of a solution. Factor in the non-technical aspect of a solution to make sure that you're meeting your recovery objectives and your SLAs.
I really like that answer because that's really what it comes down to, I think. Because a lot of these products will do the same thing. In fact, when I first got here, I wasn't a DBA, but they were using another third-party product, and it didn't quite, in this particular instance, it wasn't this, but it didn't quite handle everything. And the finger pointing was the big issue with, okay, it's their product. No, it's their product. So anyway, not to say that third-party products are bad. They're great, but it depends on what your tolerance for risk is in this case.
Totally agree.
Okay, the only other one, I'm going to let you do that one offline because it's a very specific question about a specific error message. So I think we've kept these good folks long enough. Anyway, I really appreciate it. Be sure and sign up for next week's session, and thank you, Edmund. Maybe we can get you back sometime, and I'm looking forward to the class. Thank you.
And again, thank you very much for joining us today. Really appreciate your time. And again, make sure that you take advantage of that limited time offer before registration closes on the 22nd. Again, enjoy the rest of your week. Thanks for joining in. If you have follow-up questions, shoot me an email. I'm more than happy to answer those questions for you.
Now I'll let you get back to sleep. I'll send you these questions, and you can look at them in the morning in the Philippines. Thank you.
Thank you, Steve. Really appreciate it.